Hello, everybody. Mr. Rubo here, and we're going to go over that Chapter 6 review for our quiz. All right, so we'll start with the first few problems, which all deal with those identities, those lovely, lovely identities. So when you see, for the first problem, we have sine of 40 degrees over cosine of 40 degrees minus tangent of 40 degrees. So as soon as you see sine over cosine, you should automatically think sine of theta over cosine of theta equals tangent of theta. So our theta here is 40, so we just go ahead and do nice little substitution with the sine of 40 and cosine of 40. It will become tangent of 40, and when you subtract tangent of 40 from tangent of 40, you get 0. Okay. For the second one, we see a squared. We see squareds. As soon as you see squareds, you want to use one of the three Pythagorean identities. In this case, because we have sine and cosine, we're going to use sine squared plus cosine squared equals 1. And that's exactly what we have, right? So 20 degrees is our theta in this case. Doesn't really matter as long as they're the same. So our answer is 1. No real work to be done there. Okay. Next question, we see more squareds. So for this one, we're not going to use the sine squared plus cosine squared equals 1. We're actually going to end up using the 1 plus tangent squared of theta equals secant squared of theta. Okay, so that one, if you wrote it the same way I did, I believe that was our second Pythagorean identity. But either way, it doesn't matter. So the reason why we're going to use this one is because, hey, we have secant squared and we have secant squared, so I can do some substitution, and instead of writing secant squared, I can write 1 plus tangent squared of 20 degrees minus tangent squared of 20 degrees, and just like the first problem, these two things are going to cancel each other out, which means our answer is 1. Okay. And then the last one of this type, we have tan of 72 over cotangent of 18 times, I think that's a times. It's actually really hard to tell on this copy. No, it's a plus sign. It's a plus sign. Sorry, that's a plus sign. It just didn't print out very well. And then sine squared of 45 plus sine squared of 45. So we kind of have two different things here happening. The first thing is we see like tangent and cotangent, but we see 72 and 18. So we want to see about doing something with those two different angles. So I'm going to go ahead and take cotangent of 18 and do that complementary cofunction. So the cofunction of cotangent is tangent. The complement of 18 is 72. So right away from that, I can rewrite this as tan of 72 over tan of 72. And hey, that's going to simplify really nice. But now let's deal with this. Now we want to do sine squared plus cosine squared, but we don't have cosine squared. But we do know that, thanks to the complementary cofunction, that sine of 45 would equal the cofunction, which would be cosine, and the complement of 45 is 45. So that looks like an 8. 45. Okay. So that means I can rewrite this as sine squared 45 degrees plus, and now I'm going to change this one to cosine squared. Technically, I could have changed either one, but now I have sine squared plus cosine squared of the same angle, which, we use that already on this page. That's 1. This is also 1, so I get 1 plus 1. And look at this. We actually get an answer different than -1, 0, or 1. We got the answer of 2. Okay, so there's our different properties. There's also the even odd property, which was not on here, and Was there any others that we didn't use? I guess we didn't really use the reciprocal property, but those ones I feel like you guys are pretty good with at this point. All right. So number 2 asks us if we are given the following, find the exact value of the remaining trig functions. Okay. So for these ones, you have to figure out which quadrant we're in, which in this case, it's really nice. They just straight up tell it to us. Remember, this would be 0, 90 straight up, 180 is to the left, 270 is down, 360 is back at 0. So that would mean our triangle has to be in quadrant 4, because that would be past 270 but before 360. And then we just remember our SOHCAHTOA, that's our adjacent side, that's our hypotenuse. And you either use Pythagorean Theorem or you realize this is a 3, 4, 5 triangle. The one thing you have to be careful with, though, is because we're going down, we have a negative out in front. Okay, so that negative 4 will play a difference. Again, that's the thing that students forget all the time when doing these problems. Okay, is that negative gets it for me. Okay, there, that negative is there for me. So we now have the 3 sides. So let's go ahead and find the remaining trig functions. So sine is opposite over hypotenuse, so negative 4/5. Cosine I already found. Tangent is going to be negative 4/3. And then the 3 reciprocals. So I'm going to take cosecant, or I'm going to take sine and flip it. So negative 5/4. Secant, I'm going to take the cosine and flip it. So 5/3. And cotangent, I'm going to flip the tangent. And there we go. There's all 3 of them. Okay. So there is 2A. Now let's move on to 2B. Same idea here, except for this one, we have to actually figure out which quadrant it's in based on what they tell us. So they're telling us cotangent of theta is less than 0, which, remember, that would also mean that tangent is less than 0 because the reciprocal doesn't change the sign. So all students take calculus. Tangent being less than 0 means it can't be in quadrant 1 and it can't be in quadrant 3 because that's where tangent is positive. Okay. So I then have 2 quadrants that it could be in, right? Either 2 or 4. So then when I look here, cosecant of theta equals 3. Well, remember cosecant, and I can actually do this before I even do anything. That would mean my sine is 1/3. So sine is a positive number, so it has to be in quadrant 2. Okay, and my opposite side would be 1. My hypotenuse would be 3. And now, just like the first problem, I have to figure out the last side. But unlike the first problem, it is not a nice Pythagorean triple. It is got to be, I have to use Pythagorean theorem. So I'm going to do 1 squared plus x squared equals 3 squared. I get 1 plus x squared equals 9. Subtract the 1, x squared equals 8. And I get the square root of 8, which really, if you simplify it, you could break it up to square root of 4 and square root of 2. So square root of 8 really becomes 2 square root of 2. Okay, so that's what this third side is, but it is negative. So don't forget the negative sign. I know it's kind of hard to see there, but it's negative because we're going to the left. Okay, so we have all 3 sides, which means we can go ahead and finish off this problem. So we have cosine of theta equals negative 2√2/3, adjacent over hypotenuse, and then tangent of theta would be 1 over negative 2√2, which means I have to rationalize. So actually, before my equal sign, I'm going to go ahead and change colors because I like to do that. I have to multiply both numerator and denominator, and I could just do by root 2. So you'll get root 2 over the root 2's will give you 2, but then you're still multiplying it by 2. So you get 4 and then the negative sign. So negative root 2 over 4 is our final answer there. Okay. And then we go ahead and we flip all three. Well, we don't have to flip sine because we already have cosecant. So we would flip cosine to get secant. And just like when we just did, when I flip it, oops, that's a 2. I get that root 2 in the denominator, so I'm going to multiply both top and bottom by root 2. And what ends up happening is you get 3 root 2 over 4. And then the last one is cotangent of theta. Remember, you can flip at any point, so you could flip at the end, but I'm actually going to flip this because I then get just negative 2 root 2 over 1. So there we go. All right. Took up a lot of room, but that's okay. Last one here is our sine of negative 1/3, quadrant 3. So they literally just tell us straight up quadrant 3. And opposite is negative 1, hypotenuse is 3. This should look familiar because those are the same side lengths that were in the triangle we literally just did. So I know this is 2 root 2, and it is also negative because it's going to the left. Really nice thing in this case is all of my answers are going to be the exact same, except some will be switched sign. Some will switch signs. So we already have sine. So then cosine, well, negative 2 root 2 over 3. Tangent, well, tangent would be negative 1 over negative 2 root 2. Two negatives make a positive, but again, we've already done all that work to rationalize, so I'm just going to take the answer from before and just make it positive. And then we have the 3 reciprocals. So when I reciprocal sine, I get negative 3. Reciprocal cosine, I would end up getting 3 root 2 over 4, and it would still be negative. And then cotangent ends up giving me positive 2 root 2. Okay, so part C, if you did part B, part C was actually not as much work because you already did all the work. All right. So now the last ones on this page is this little bit of matching. So when you look at, you could either start with the graphs, or you can start with the functions, the equations. Here we have an amplitude of 3. This one, it just has a vertical shift of 4, like up 4. Here we have a period change, and it would be 2 pi over 3 is our new period, right? Because that's, you always do 2 pi over the number. And then this is just a reflection, right? A reflection over the x-axis. So if you know that, you just kind of look through each one. So let's go ahead and kind of just look. Okay, so this one, amplitude of 1. It is, and I guess we should have also pointed out, they're all sines, so we can't really look at that either. So it's a positive sign because it's starting to go up, but then you'll notice the period, this is one period. Remember with sine, you go to the very top, you go back to the bottom, and you come back to the center because you always have to end and start in the same spot. Now, I didn't make this graph very well with the scale, at least, when I put it on the computer. But we can definitely tell it is not 2 pi, which means our answer for which one this goes with is choice lowercase c goes with graph A. All right. If we look at the next one, my center line is at 4. So right away, that tells me vertical shift to 4. You don't really even have to do too much because now we know it's going to be this one. It has an amplitude of 1, period of 2 pi, so everything else is the same. But yeah, we got period vertical shift of 4. Okay, this one, again, center line's there. Oh, my amplitude is 3. There was one that had amplitude of 3, and that was equation A. So that means C goes with that one. And then obviously the only one left is D for D. And that's because we go, down first. Okay. So there's the first page. Let's go ahead on to page 2. Sorry, this is going to be a longer video, but I just wanted to do it all at once. Okay. All right. So for 4, we are asked to graph given the function. They tell you here to name the amplitude period and vertical shift, and then sketch at least one period of the function, and be sure to scale both axes. So remember, you are putting the numbers on the axes because that's really what changes with a lot of these graphs is just the axes. All right, so our amplitude here, if you look in front of sine, there's nothing in front of it, which means it's really a 1 in front of it, so there you go. Our period comes from, didn't want to change colors there. Period comes from that number, but we actually have to do 2 pi over that number. And then we do the keep, change, flip, and the 2's cancel, so you end up getting 3 pi. And then our vertical shift is this plus 1, so you could say up 1, plus 1. I don't care how you say it. But yeah, so we're going to go ahead and start. I like to always start with the x-axis, so the 4th tick mark, 2, 3, 4, is going to be 3 pi. The first tick mark in the x direction is going to be 3 pi divided by 4. And now I know this is what I'm counting by. So I've said it before, I don't really care if you don't simplify on your scale. So you can see like, 3 pi fourths plus a 3 pi fourths would be 6 pi fourths. And then 9 pi fourths. And then you get 12 pi fourths, which would be 3 pi. Okay, so if you didn't simplify this to 3 pi over 2, it's not the end of the world. Okay. Vertically, though, I am going to go up by 1s because my vertical shift and my amplitude are both 1, so that is helpful. All right, so let's deal with the vertical shift first. There is my center line, right? So there's my center. If I'm going up 1 for my amplitude, there's my max. And going down 1 for my center, there's my min. Okay. And we have everything we need now, except for what color I want to do it in. All right, and then we look and we see it's positive sign. So positive sign means on the y-axis, you start at the center. And then because it's positive, you move next tick mark, you move to the max. Then you move to the center again because you can't go any higher than the max. You keep moving down until you hit the min. And you come back to the center and you connect it as best you can in that wave fashion. And there is one period. If you wanted to, you could throw on another period by following the same exact pattern, right? So there's exactly enough on the right side to do a second period. Or if you wanted to, you could also go backwards and reverse the pattern. So remember, the thing is you want to look exactly the same. Just repeat it over and over again. Again, you want to make sure you label all 4 tick marks, label your y-axis. You don't need the guidelines like I have them in red, but I find them super helpful, so that's why I have them. All right, and then the last questions here are the writing the equation of these graphs. So I'm going to go ahead and start by doing those guidelines. So here's my min, here's my max, which means my center is right there. So as soon as I see my center being not at the x-axis, I know my vertical shift is +2 because that's where that is. I also can hopefully see my amplitude is 3 because that's this distance between the center and the max, or the center and the min. Okay, and then I look and I see my period is 2 pi. So then that would mean my W which is what I actually put in the equation, would be 2 pi over 2 pi, which is just 1. And then I have everything I need, except I now need to just make sure it's either a sine versus cosine. And we're starting at the center, so it is sine. So it'd be, and it goes up, so it's positive sine. So positive 3 sine of, and it would just be 1x or just x, and then plus 2 at the very end. And that's the answer for number 5, A. Okay. So the next one, same idea. I'm going to go ahead, max, min. I did that backwards, but that's okay. So my center is right there. So that means there is no vertical shift because it's at, the center is at 0. My amplitude, though, is 2. And my period, if you can't see that, that is 1. So my period is 1, which means my W is going to be 2 pi over 1. So actually, in my equation, 2 pi is going to show up. And I was not very creative with these. I think they're actually all signed because I didn't really pay attention to that when I was making these graphs. But yeah, this is a positive sine, amplitude of 2. And then it's 2 pi x. And then it'd be plus 0 because of that vertical shift being 0. Okay. Okay. The next one, second to last one here. So for this one, again, I go, hey, there's my max, there's my min. So that's my center. So vertical shift is down 2. My amplitude is 1/2. We're going to assume that's 1/2. It's pretty close. And then our period is 4 pi. So again, we want the W though, so we want to do 2 pi over 4 pi. Simplify this and we get 1/2. And again, my creativity has no bounds. It's a positive sine function. So it's 1/2 sine of 1/2 x minus 2. And there we go. And then this last one, our max is up here, min down here, so the center is here. So that means our vertical shift is 0. Amplitude is 4. The period, don't get tricked with this one. The period is just 2 pi, right? We actually had a few periods drawn here. So it's the normal period, which means W is 1. And then again, my creativity, it's another positive sign. So it's going to be positive 4 sine of x. No vertical shift, no change in period. So not too many transformations on that one. Okay. So yeah, there is our review. Hopefully you understand and have a good day.